of this video is probability. In everyday life, we will come across some statements like mostly it will rain today. There are chances that the prices of petrol will go high, or I doubt he will win, like that. So, all these words, most probably, chances, doubt, all these are the probability of occurrence. That means it may occur or it may not occur. So there is something called experiment and random experiment. In probability, we use the word random experiment very commonly. That is, one experiment, one action has to happen, and in that, the possible outcomes are not known. We don't know what will occur in that experiment. For example, we know very well when you throw a coin, so we watch cricket matches, all that. In that, they throw a coin to, and they will ask whether you want a head or a tail. We know there are two possibilities, head and tail, but which one will occur at that point, that we do not know. This is called random experiment. There are so many experiments and their outcomes generally in the probability, and in this video I will be dealing the probability of the basic things like 8th standard, 9th standard, 10th standard probability things only. Probability will start from 8th grade and go till 12th grade. The complexity will increase, and it is a very easy chapter where the students can do easily, with the mental math only they can find out the answers, but there are some basic steps which has to be followed. Only the steps matter, but the answers and all that will be very easily done by the students, and students can get full marks in probability chapter. That is the very positive thing about the probability. Now I will be explaining you what are some experiments and what are their outcomes, all that. I will explain you some experiments and their outcomes. The first one, very important one in probability, is tossing a coin. So when you toss a coin, you know very well this is very easy and everyone knows it because everyone watches cricket matches and all the matches where they will toss a coin, and they will get either head or tail. So which one will come, that we do not know. That depends on that particular experiment. So whatever comes up, that is called the outcome of that experiment. And what are the possible outcomes? Heads or and tails. So these are the two possibilities when you toss one coin. And the next one is tossing two coins. See, in probability, if you toss two coins or if you toss one coin and after that the same coin if you toss again, both will be considered as tossing two coins only. So when you toss two coins, what will be there? So first coin you may get head and in the second coin also you may get head, or in the first coin you may get a head and in the second coin you may get a tail, or in the first coin you will get a tail and second coin you will get a head, or in first coin you will get a tail and second coin also you will get a tail. So there are four possible outcomes in this. Those possibilities are HH, that is first coin head, second coin head. HT, that is first coin head, second coin tail. TH, that is first coin T, that is tail, and the second coin head. And the fourth possibility is TT, that is in both the coins you will be getting tails. And the next one is throwing a die. When the children, they will be playing with a die, right? So in a die, one die, it has 6 faces in that. We call it phases. So in the first phase you will have one dot, in the second phase you will have two dots, like that, 3 dots, 4 dots, 5 dots and 6 dots. So there are 6 faces in a die, and when you throw a die you will get one thing, one face only up. The remaining all will go under, that and all we will not consider. So what can be coming up? They can be 1, 2, 3, 4, 5 or 6. Any one can be coming up when you throw a die. And the next one, very important one, drawing a card from a well shuffled deck of 52 cards. The playing cards are there, right? People used to play that cards only. We have normal cards, we have 52 cards. So how they will be arranged, this I will deal in detail, and then we will go to the problems. There are 52 cards, and the 52 cards will be separated, segregated into 13, 13, 13, 13, like that. Four suit of cards. Suit. S-U-I-T. That is called a suit of cards. Four suits are there. S-U-I-T-S. So, four suits are there. Diamond, heart, clubs and spade. 52 cards are segregated into four suits, and that four suits are diamond, heart, club and spade. Each suit we will have 13 cards each. Each suit will have 13 cards. I will explain this also in detail. See, we have 52 cards. This spade and club are black cards, and diamond and heart are red cards. So, spade and club are black cards, diamond and heart are red cards. So, we have 52 cards, we have 4 suits. Every suit will have 13 cards each. So, therefore, black cards, no, spade and club, they are together, we have 26. And the red cards, that is diamond and heart, are again 26. And in each suit, if you see, spade, club, diamond, heart, each one will have one king, one queen, one jack, one ace, and then numbered cards. Numbered cards start from 2 and ends with 10. Once again, I'll explain. Each suit will have one king, one queen, one jack, one ace, and numbered cards 2 to 10. So totally we have 13 cards. So these many cards are there in each suit. Spade and club are black cards, diamond and heart are red cards. So black cards are 26, diamond and heart both together, red cards are 26. Now again, still more. Now if you see, in the deck of cards, there is something called face cards. Face cards means, see, A's will not come under face cards. A is A only. Face cards means king, queen and jack. Only these are face cards. So, put together all the four suits are there. No? Each suit has 3 face cards. Each suit, heart means heart has one king, one queen and one jack. That means all the 4 together we have 12 face cards. So all the 4 together we have 12 face cards. And the numbered cards are 2 to 10. We have numbered cards, that is 2 to 10. And then we have ace cards, that is 4. Like that it will be. So once again I'll tell you, deck of cards, we have 52 cards. In that, heart and diamond are red, and spade and club are black. Red cards, one suit, that is heart is one suit, diamond is another suit, like that. So each suit will have 13 cards, and red cards are 26, black cards are 26. Face cards, for each suit we have 3 face cards for each suits. One suit will have 3 face cards. So together we have 4 suits. So 3 into 4, 12 face cards are there. And then 2 to 10 are the numbered cards, and A's are there. Okay, so this is in that. So in summary, once again I'll tell you, when you toss one coin, the possible outcomes are head or tail. When you toss 2 coins, the possible outcomes are HH, HT, TH and TT. When you throw a die or roll a die, the possible outcomes are 1, 2, 3, 4, 5 and 6. Only this much. In a drawing card, in drawing a card of a well shuffled deck, why they say well shuffled? You are not arranging it in any order, you are just shuffling the cards. So we have 52 cards, and in that 52 we have 4 suits. Each suit will have 13 cards each. The cards are 1 ace, 3 face cards, that is king, queen and jack, and the numbered cards 2 to 10. Each suit will be having all this. The first question is, in a single throw of a coin, what is the probability of getting a tail? This is very easy, but there are few steps which should be followed. So I will be explaining you everything with the help of problems only. Okay. So now the answer is, see, I have already explained you, when you throw one coin, we will get either head or tail. So everything should be properly written in probability, because answers are very easy. So now in tossing a coin, all possible outcomes are H and T. Okay, H means head and T means tail. Only these two outcomes are there. So now first thing is, therefore, total number of possible outcomes. Total number of possible outcomes. What are the total number here? Head or tail. Two possibilities are there. And then what is the question? What is the probability of getting a tail? So number of tails. How many tails are there in one coin? We have only one tail. So 1. Therefore now probability how to do is P of getting a, like this only we have to write. P of getting a tail. P of getting a tail is the probability of the number of tails divided by the total outcomes. That is, whatever we require divided by the possible outcomes. So whatever we require is the number of tails, and that is 1. And the possible outcomes here are 2. So it is 2. So probability of getting a tail is 1 by 2. Here I will tell you one more thing. The maximum probability will be equal to 1 and the minimum probability will be equal to 0. There is nothing uh, below 0 or above 1. So 1 by 2. This 1 by 2 is less than 1, but it is greater than 0. So this probability is correct. Probability should be always coming between 0 and 1, both included. 0 also included, 1 also included, but it cannot be less than 0. Less than 0 means it will be negative. Negative values are not allowed. And more than 1. If you get a probability value as 2, then the answer is wrong. So everything should be falling between 0 and 1. All the fractions, decimals are all allowed. Less than 1 and greater than 0 if it is, then all the fractions and all the decimals are allowed. So this is about the first question. Answer is very simple. When you see, you can easily tell me the answer. That is, probability of getting a tail. How many tails are there? Only one tail. What is the possible outcomes? Two possible outcomes, head and tail. So 1 by 2. This is a mental calculation only. But when it comes for a probability problem, we have to write all these steps. Now the second question. In a single throw of two coins, find the probability of getting both tails, at least one tail, at the most one tail. So there are three questions in this. This is not one question, it is like three questions, equivalent to three questions. But even though if it is equivalent to three questions, it is based on single throw of two coins. So when we have to write the total possible outcomes, we have to write it once only. So, first thing, before writing A, B, C, we will write the total possible outcomes. This also I have already told you. When two coins are tossed, every steps are important in probability. When two coins are tossed simultaneously, see, simultaneously, or if it is tossed one by one, whatever it is equivalent to tossing two coins only. The possible outcomes are. So what are the possible outcomes? I have already explained you. HH, HT, TH and TT. So how many possibility are there? Total possible outcomes. It is 4. Total number of possible outcomes. That is equivalent to 4. We have 4 possibilities. Okay. Now we will do the subdivisions. Now A subdivision, first subdivision, but that is both tails. So now we have already written the total number of possible outcomes outside this ABC because it is common to all the subdivisions, all the 3 subdivisions. So now first one, both tails. So getting both tails. What are that? You want both, in both the coins we want tails. So here we have 2H, here we have H and T, here T and H, here only we have both tails. So only one possibility. So what is the number of possibilities, number of outcomes for our requirement? Number of outcomes is only one in that. So therefore P of getting both tails is equal to this one divided by the total possible outcomes, that is 4. Whatever we need divided by the total possible outcomes. This is 1 by 4 which is less than 1 but greater than 0. So on seeing only we can tell the answer. These are all mental calculations. So we require all the steps here. We cannot omit even a single step. Now we'll see the second subdivision. At least one tail. B problem is at least one tail. See, at least means it is minimum, like that. At least means minimum. So minimum we want one tail. So getting at least one tail. One tail minimum we want. So if there is, see, we'll see this. So here the possibility HH, there is no minimum, no tail in this. HH is we don't have any tail in this. But here we have one tail, here we have one tail, here we have two tails. The remaining all the other has tails in that. We want minimum one tail. So maximum two tails is also allowed. So we can remove that HH because it does not have any tails, but the remaining all have tails. So minimum one tail, maximum any number of tails. So TH, HT and TT are the required. Whatever we require is that only. Okay. And therefore number of outcomes. So number of outcomes is equal to 3. 3 we can get. Any one if you get also okay. Therefore P of getting at least one tail is equal to the number of outcomes is 3 and the total possible outcomes is 4. So our answer is 3 by 4. At least means minimum one tail. These words are very common in probability. At least, at most, all that. Now I will teach you what is at most. At the most one tail. At the most means minimum. Oh, sorry. At the most means maximum. At the most means maximum. Maximum one tail. Minimum it can be 0 in this. Okay. So we'll go and see here in our possibilities. Here we do not have. See, maximum one tail is allowed. Minimum 0 tail is also allowed. Like that. Okay. Maximum one only. So we cannot have this TT here because it has two tails. Maximum only one tail is allowed. Minimum even if you don't have tail is also fine. So HT is allowed, TH is allowed and HH is also allowed in this case. At most means maximum. So getting at the most one tail. So what are the possibilities we have? We have one tail is allowed. So TH and HT. And two tails are not allowed. So remaining we have HH. That is allowed because maximum one tail. Minimum 0 tails like that. So therefore number of outcomes. How many outcomes? There are 3. TH, HT and HH. Therefore probability of getting at the most one tail. At the most, one tail is equal to, the required is 3 and the total possible is 4. So answer is 3 by 4. As the video size is becoming big, I will explain the remaining problems in another video. So please keep watching. There are almost 11 problems for probability. I will explain all the 11 problems. Please keep watching.